All right, so chapters 1 through 11 through 12, or 13. Chapter 11, we started by introducing organic molecules and functional groups. You should be able to tell me primary, secondary, tertiary, and quaternary carbons. That just means 1 carbon's attached, 2 carbons attached, 3 carbons are attached, or 4 carbons are attached. Pretty easy. You need to be able to recognize parts, like this is a carbonyl, this is an ester oxygen group. This over here is an alcohol. This is an ether right here. This is an amide right here. This is an alkene. You need to be able to navigate all of them. So really quickly, I'm going to have people come up and highlight the longest chain in each of these and tell me what it would be called. So here we go. Number 1, Kyle. And I'm just going to go across like this. 1, 2, 3, 4, 5, and 6. Here we go. Number 1 is Kyle. Number 2 is Alex is not here. Number 1, Kyle. Alex not here. Jaron. Is Jaron here? No. Catherine. Number 2. Cambry. Number 3. Emma. Number 4. Richard. Number 5. And McKay. Number 6. You're not naming, you're just highlighting the longest chain. And tell me how many it is. Yep, just highlight the longest chain, tell me how many it is, how many are in the longest chain, and what that longest chain would be called. The longest chain, just the longest chain. There should only be 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, there's 11. It's dodecane. Just put 11. That's fine. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11. Okay, so first of all, you need to be able to quickly recognize, tell what the longest chain is, and give the name. Sorry about the one on the 11, because we're only going up to 10. Okay, going forward, I am not going to wait for everybody to listen. I'm just going to go. Okay, so how many hydrogens do each of these have? And I want you to tell me if it's primary, secondary, tertiary, or quaternary. Remember, you're writing it like this for that. And yet that is going to be just outside the box. Inside the box, I want you to put how many hydrogens. Luke, you've got number 1. Noah, 2. Joshua, 3. Andre, 4. Calvin, 5. And Ben, 6. So in the box, tell me how many hydrogens are attached, and then outside the box next to it, put me what kind of carbon is it? Primary, secondary, tertiary. Wow.
That's what we call a big mixture. So we have 3 hydrogens attached.
3 carbons attached, so there's 1 hydrogen. So it's 1 hydrogen in the box, and then outside you would put 3 degrees. So the 3 tells me 3 carbons are attached. Okay, really quickly going over this real fast. Number 1, on the very end, you would have 3 hydrogens attached as primary. Number 2, it's in between 4 carbons, so there's no hydrogens, and it's quaternary. Here you would have 2 hydrogens attached, and so it's secondary. Here you have 3 carbons attached, so it's 3 degree or tertiary, and there's 1 hydrogen. Number 5, 2 again, secondary, and number 6, the very end one, would have 3 hydrogens, and it's primary. Going forward, We need to be able to tell what class that is. This means, is it an aldehyde? Is it an ester? Is it a ketone? Is it a amine, amide, and carboxylic acid? Is it whatever it is? So here we go. You're going to look this up. This is in number 11. It is in that packet, if you have that packet with you. If not, you're going to have somebody help you. Here we go. This is something that you do need to be able to do for the test. So, number 1 is Kyle again. Okay, number 2, Catherine again. Number 3, Cambry. Number 4, Emma. Number 5, Richard. Number 6, McKay. Number 7, Luke. Number 8, Noah. These all only have 1. If it has a double bonded O and an OH, it's something else.
Oh, yeah.
Which one do you have?
I have number 6.
So that would be,
That's the something else. I thought acid was like number 2. Just a double.
number 2 is a ketone.
Oh, yeah. I remember now.
Okay.
I was like, I got 100% on the 6. I don't remember this.
Okay, if you do not remember this, this is something I would put on my card. You need to be able to recognize these.
Okay.
Five. Okay, let's get it up there.
I have no idea what 7 is, I'll be honest.
It has a nitrogen in it.
Yeah, so
So if this one is an amide, this one would be a, if this one is a mid,
what would this one be?
that's what we made in lab. The smells. What were the smells?
I have no
I heard it in the background. Yep. Okay, so let's go over these really quickly. Shh. Coming up front. This is an aldehyde. Good. Double bound oxygen on the end of a chain is an aldehyde. One that's in the middle of a chain is a carbonyl, but it is called a ketone. Okay, so we need to know that it's a ketone. An OH tells me it's an alcohol. So in the middle of a chain, ketone. At the end of a chain, aldehyde. If it's in the middle and looks like oxygen on both sides, that is an ether. Remember, just ether this or that. Okay. If you have this combination, it is an ester. If you have the double bound oxygen and O at the end of a chain, it's an acid. If you have a nitrogen, nitrogen, by the way, is the poison column. It's mean. So if you remember it's mean, then it's either amine or it's amide, because it's amid something else. It has a double bound oxygen with it. Okay, you need to be able to recognize and match the name. Okay? Yeah, they're not pleasant. Okay, going forward. Okay, chapter 12, we learned a song. 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 heptane, 8 octane, 9 nonane, 10 is decane. Now you can name organic chemicals if you know these 10. If there is a double bond, you change the ending to ene. If there is a triple bond, you change it to yne. Okay, so that was a song that helped us through chapters 12 and 13. When we're looking at 12, we're also going to be working with single bonds, and we're going to work with cyclics. Okay, so you need to know the basics. We learned how to name here. We need to be able to figure out the molecular formula very quickly. In order to do that, we need to have the formulas. So what was the formula for an alkane? Good. What was a cyclic alkane? Good. All right, so I'm going to have you come up and do these really quickly. Here we go. Number 1 is Joshua. Number 2 is Andre. Number 3 is Calvin. Number 4 is Ben. Go, go, go. I'm going to keep you hopping up here and back because this is an active review. This is not a sit on your butt review. That's right. It's going to be get up off your butt, get up off that thing, shake it, you'll feel better. So what do we do? Just up above. Which one did you get? Okay, so you put C6. It's a cyclic alkane, so you can take that number, times it by 2 for the H.
That's 4.
No, 6 times 2 is?
Oh, 12.
Yep, done. That's it. That's it. Except it's supposed to be little. See, now it'll work. Okay, so these should be very fast. Okay, we're moving on. This okay? All right, moving on. You have 2 things here that you need to name. I am going to number them. This is a cyclic. These are stereoisomers. What are stereoisomers? Cis and trans. So one is cis and one is trans. Here we go. Number 1 will be Kyle. Number 2 will be Catherine. That doesn't mean the rest of you shouldn't do them. Try and figure out what the name is quickly.
Wait, do you just need it? Do you need like trans, brom, something?
Trans, tell me where they're at. Then tell me how many. And then do the cyclo.
So it would be like trans, 1, 2, dibrom,
Mo, bromo.
bromo, cyclo, 1, 2, 3, pentane. You know, it's like evidence.
Okay, so go put it up.
I remember stuff.
Good, good. You just got to remember it for the final.
Right.
It's 20%. You got to do all of it.
I know. I'm gonna do good and hopefully.
I'm hoping so. You got it. Okay, so they both say 1, 2. She just had a little problems there. That's good. Anybody have questions with how they were named? Okay, here is my big, big, big stress to you. Whenever she has you name something like this, it'll be multiple choice. Do not look at the multiple choice. Draw this down, write what you think the name is, and then look up. Because what do you think she's going to leave off? Di, cyclo. She'll number it differently. Okay, and if you look at her answers, you're going to be swayed by the most common mistakes. So write it down, figure out the name of it, then look for that name. Does that make sense? Okay, so going on. Whoa, hold on, why? Okay, so because of this right here, they're the same here, both coming out. So that's cis. Here they're different, so they're going like the Egyptian. They're going to be opposite, so that's trans. So if you looked at this sideways like this, one would be going up and the other one would be going down. That's trans. So the hydrogen would be opposite it, like this. So that's trans. This other one would be written like this, and it would be showing up, and the other part would be down and down. Okay? When they're cyclic and they're right next to each other. So that's for the anes. Okay? We also have cis and trans with double bonds. Okay, but we can do it with cyclics for the alkanes. Okay, tell me really quickly, how many bonds does carbon need? How many hydrogen? Oxygen? Nitrogen?
2, 3.
Sulfur? Halogens? Okay, what shape does this make? What's the angle? What's the angle here? Or what shape? Okay, what's the shape here? What's the angle? Okay, about 109.5, but it's really about 105, right? Okay, nitrogen. Pyramidal, because it has an unshared pair of electrons. What is the angle? But it's really... Okay. What about sulfur? Bent. Therefore, it's going to be about 109.5, which is really 105. I should put degrees here and here. Okay, what about the bottom one? Linear. I'm not going to write it. Okay, going forward.
Thank you.
It's all one. It's all one. There's 50 questions. There's 50 questions. So chapters 1 through 5, there were 13. Chapters 6 through 10, there were another 18. And the rest are chapter 13. Okay? Well, chapter 11, 12, and 13. Okay, we'll get there. So 13 right here is unsaturated. So this is where we're talking about double bonds and triple bonds. Okay? When we talk about double bonds and triple bonds, when we make a double bond, it goes into a plane, right? When we do a triple bond, it goes into a line, right? Because we have this in a plane, we can get things that are in trans, or we can get things in cis. And I'll just do it right here. And we'll do this as cis. Okay? All right, going forward. What's the general formula for an alkene if you have one double bond? Done. What if it's cyclic with one double bond? -2. What about an alkyne? CnH2n -2. What if it's an alkyne cyclic? Okay, if it has more than one double bond, you just keep subtracting 2 for every bond. Okay? All right, so I'm going to have people come up. Let's see what we do here. Cambry 1, Emma 2, Richard 3, McKay 4, Luke 5, and there's no 5. You're going to be next. Okay, quickly as you can, get the answers up. No.
That's not it.
Let's see, 9 times 2 is 18 minus 2. Yes, 18 to 16, yep. There we go. Okay, who was my 4? McKay. Where'd McKay go? That's right, he went off. Okay, so I'll do McKay's real quick and we'll come back. So, C8, H, 16 minus 4 is 12. Okay, everybody okay with how this has gone? Anyone that you disagree with?
I disagree with 4. What do you mean? I don't get it.
2n, 16 minus 4 is 12. Okay,
Alright.
okay, going forward. These are ones that most kids have problems with. Please watch this. As you're doing this on the test, don't leave it in the condensed form. Write it out as a structure, not line, but just as a structure. So this is what I do as I'm doing it. I say, okay, I have 3 carbons attached to 1 carbon. So here's my 1 carbon. Here's 1, 2, 3 carbons attached. I've now done those. You see that? Go on to the next one. I have another carbon attached. It has 2 hydrogens. I'm not going to write the hydrogens. Okay? Then it's attached to another carbon that's double bound to a carbon. Everybody okay with that? That carbon, since that CH3 is in parentheses, has another carbon coming off of it. Taking care of that. Now I've to the CH2, which comes back to my main chain, and the CH comes off that. Then I have one last carbon right here, and I have 3 carbons coming off it. Everybody okay? At this point, now I try and figure out where my longest chain is. Well, you know me, I don't like to go straight line. I could have gone straight line, but I'm not going to because I don't want you to get used to it. I'm going to say this is my longest chain. Okay, and I've got 1, 2, 3, 4, 5 methyl groups attached to it. I also have a double bond I need to worry about, right? Which way am I numbering? Am I numbering from the right to left or left to right? I heard both. It does matter.
Actually, it's right to left. It's right to left.
It's right to left because if you look at the double bond will be on 4 either way. But on the right-hand side of the double bond, I have 3 methyl groups. On the left-hand side, I have 2. So to get the numbers lowest, I go start here. 1, 2, 3, 4, 5, 6, 7, 8. Everybody okay with that? So at the very end of the naming, I would put, what's 8? Octene. Okay, where's octene at? Where's double bond at? 4. So I put in front of it 4 dash. What else do I need to say now? What do I have? What's the groups coming off? Methyl, right? How many methyl groups do I have coming off? What's the prefix for 5? Penta. And I put in front of that, where are those groups?
2, 4, 7, 7.
Okay, and we got it. I want you to do the bottom one on your own. Go. Everyone.
Start with a C.
I was about to do it on my page.
We got a lot of scratch paper back there.
I'm being environmentally safe right now. I am a Democrat.
Where are the mice?
Back at the back. Oh, the mice are right there in the black crate.
Ah, yes.
Nope, those are not mice next to it. He ceased said, as he ran into the tree.
Yes. Also, you know what I see? That's my jacket. It's been there for a while.
Please take it. Please take it. Okay, I'm going to do it slowly. If you're having struggles, I'm going to slowly draw it out. Okay? I'm going to leave it there for a minute. Here. So if I circle, that's my original, that's my this one, then that's a 3 right there. Try it again.
Oh wait, the phone. I'm trying to.
Okay, how'd we do? Did we get that?
We did. Wait, two.
There's 2 methyl groups off.
I got messed up. I did 1-1, sorry.
Yep. Can't do 1-1 or that make the chain longer.
Yeah, wait.
Okay, going forward. Here we go. We are going to name these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we go. Luke 1, Noah 2, Joshua 3, Andre 4, Calvin 5, Ben 6, Kyle 7, Catherine 8, Cambry 9, and Emma 10. Okay, make sure you write the one that you've got down real quick, so, or that you name it real fast. Normal IPAC. If it has a cis or trans, make sure you put it in. Some might look like it, but remember they have to have 2 of the same, 1 on each side of the double bond. Mm-hmm.
Cis, right?
Mm-hmm.
So that would be
Cis. Go ahead and write cis.
This is beautiful, right?
Where's the bond at?
Is that just butyl?
So what carbon in? 1. So dash 2.
You're probably right, actually.
Dash. How many total? Which is? Butene.
The what?
Butene. E-N-E. B-U-T. E-N-E. E-N-E. E-N-E.
got it.
You got it? Okay.
We're getting now!
Yeah, which one?
10.
So 10 is trans, right? Because it
Yeah,
goes
because
across.
it's-
Okay, so unfortunately we don't have
Spell beauty. Put an M there.
So it would be trans, and then we count in 1, 2, 3. So trans 3, 1, 2, 3, 4, 5, 6, 7, which is
I don't know this one.
hept, heptene. Okay.
Sorry, so this is a paragraph. It's a double bond, so I have ene at the end, and I have
But
one.
no, you're not going to do that. You've got to do the whole chain. So 1,
So
2,
what did
3,
this
4,
be
5,
considered?
6, 7. 7 is
So
what?
each C. 7 heptene.
Hept, and this is in a cis formation because the hydrogens are on the same side. And then what carbon? 1, 2, 3. So it's just off carbon 3. So cis dash 3 dash heptene done.
3 dash.
And you heptene done. Yep, just that.
But I'm not sure, like with the
3,
double
4
bond.
dimethyl. This should be 2 hexene
Okay.
because you count this way. 1, 2. The
Oh,
shortest
that's
way.
right, yeah.
Bond, James Bond. They always win.
Okay. Isn't that gonna be the same thing? These are two different things for T6.
You got hydrogens.
Oh.
YL.
And then I'm gonna have to go like
Yeah.
You just threw away my birthday gift.
Okay, let's double check these really quickly. Okay, number 1, correct. 1-butene. Number 2, 2-methyl, 2-pectene, correct. Number 3, oops, you got a problem. What'd they forget? The ethyl. So what do I do with the ethyl?
Alright, so 3 ethyl,
3 ethyl, and then 2-pentene. Okay, next one. Cis 2-butene, good. Trans 2-butene, good. Next one. 3,4-dimethyl, 1-hexene, good. Trans 3,4-dimethyl, 3-hexene. Next one. 3,4-dimethyl, 2-hexene. What do you notice about these 3? Right here. They're all going to be the same kind of molecular formula. So they're going to be constitutional isomers. Okay? This one should have had a cis in front of it. Why? Those two are the same. So this should have had a cis. What about this one? That one should have had a trans. It did. What about this one? Why don't we put them there? Because these two hydrogens are the same. Okay, going on. Cis 3-heptene, yes. Trans 3-heptene, yes. And we're good to go. You got hydrogens that are the same. Okay? All right, next one. We're going to draw the structure. Please, when you draw structures, when you go to look at structures, start at the back end and work forward. So I'm going to do number 1, and I'm going to farm out the rest. So pentene is what? 1, 2, 3, 4, 5. ENE tells me double bond. Where's the double bond at? 1, 2. Then I go back forward and I say, oh, I have 2 methyl groups. Where are they at? 2 and 4. Done. Now I can add back in the hydrogens if I need to, but I've got it. Okay, I can also get from this structure 1, 2, 3, 4, 5. I can quickly draw maybe the line structure. Okay, so here we go. Numbers 2 and 3 are Richard is 2 and McKay is 3. Okay, go.
Alright.
Get up there and draw it. The rest of you try it. On your own.
Wait, what does it mean? Are there? Oh, there's 2 double bonds. That's what it's
Oh, yeah, you're right.
Good. Good job, Richard. Okay, good job, McKay. All right, why didn't they put cis-trans on this one right here, the bottom one? It's got double bonds. Why didn't they have cis-trans on either one of them? Well, it doesn't say, but this one does. This has 2 different things, chlorine, and this one has hydrogen and this big thing. This one doesn't have a hydrogen. So there's not 2 that we can see that are trans or cis. Okay? All right, going forward. We got different structures here to look at. So we've got 1, 2, 3, 4. Okay. These people are naming these. So let's see, where was I? Who did them last? I just had one of those moments. Okay, Luke, 1. Noah, 2. Joshua, 3. Andre, 4. Trans is like an Egyptian. If you put the hydrogens in really quickly,
What?
here's a hydrogen, here's a hydrogen, that'll help you. They're opposite.
So these ones shred.
This one's neither cis or trans because it's got 4 different things coming off. So you can't do cis or trans. So just name it. Well, it's the longest. So this is your longest chain, right? So how are you going to number it? Which side do you start with?
This side?
This side, because this is the first thing coming off. So 1, 2. And you have a methyl group, and you have a bromine group, and you have to name that. So,
This one isn't going to be cis.
We're learning.
no cis or trans.
That'd be bad.
Trans goes the very first.
Is cis spelled CIS?
So you're going to start numbering here. So you go 4 bromo. Dash. Next group is a methyl, and it's at number 3. So go 3 methyl, dash methyl, and the chain is 7 long. And where's the double bond? 3. So you go dash 3, and what's 7 long? Heptene. E-N-E. N-E. Okay?
Oh, no, it's not in no.
Oh, you're all right. You just put me on there. You're good. Okay. Let's go through these really quickly. Shh. Okay, so this is a trans. because it's opposite. This is lower, this is higher. And at numbers 1, 2, 3, 4, 5, 6, we just have one group coming off. You see that? So I don't know exactly what this is, but it should be 4-methyl, and then 2-2-hexene. Number 2, this position here, this is cis. When you make a bucket, or that's going to be cis. Okay, so cis is right. Numbering, it doesn't matter if you start whatever side you start on because it's a mirror image of each other. So 2,5-dibromo-3-hexene, correct. On the bottom here, starting here, 1, 2, 3, 4, 5, 6, 7. 4-bromo, 3-methyl, 3-heptene, yes. And this is the exact same thing. We're not talking right now, but these are enantiomers of each other. If you go on in chemistry, they are different, but we don't know the difference right now. We would name them the same, okay? All right, they are not cis and trans, so be careful with that. All right, we've got some more to name, more things that we need to remember. So, going again, and you guys come up. Told you you'd be up here many times. Here we go. Number 1 is Calvin. Number 2 is Ben. Number 3 is Kyle. Number 4 is Catherine. Number 5 is Cambry. Number 6 is Emma. Number 7 is Richard. Number 8 is McKay. Yep. Number 3? They could switch back and forth, but we don't know. We don't do alcohol. It's not an alcohol. It has a special name. These have special names. You need to make sure you're looking up the names. Nope. Every single one's unique. You are, let's see, McKay's 8, so you're 7. Yeah, but no dash in between. And you don't use a 2. You don't use a 2. What do you use? Yeah, that's what you use. You just said it. Dash. There you go. Okay. Nope. Nope. Go look up again.
We ain't gonna look up again.
Because that's not it.
Why?
Because that's not his name.
The longer I look at it, the less I know.
Shame. So I'm just gonna send it right now.
Number 7?
Yeah.
He gave you a hint on number 3. Yours is simple.
Not methyl.
Not methyl. Oops. Zero it back on the board.
Oh, I was like, what am I looking at? Not methyl? What's
That's a toluene. This is a nitro.
Yeah,
So
I know
P,
it's a nitrobenzene.
nitro toluene.
So it's a nitrotoluene.
It's a P
So
nitro
this one
toluene.
takes precedence over this one.
This is a group, yep.
I thought this was the group, the nitrobenzene.
But you had to do nitrobenzene. This right here has its own name, toluene.
Okay. So toluene. How do you even spell that?
Come here.
We should just use the eraser.
Methyl, O-methyl, so O means right next to each other, toluene.
Okay.
So without that, it's just toluene. T-O-L.
And then I just put nitro through it?
No, you go
Tol.
P-nitro.
Oh, nitro first. Okay. Nitro.
No, this would be this, but this
Oh yeah,
thing
'cause
changed.
it's P because it's two
No.
apart.
I just met you, so give me some space. P is opposite.
Wait, so what's this one?
M.
M, okay.
Yay! You found it. Okay, who's my 2 and who's my 5?
Figure it out.
Dan, which one is it?
Well, that's like, is it cyclobenzene?
This has to do with that mean column.
Yeah, I don't know. I like my
This mean column's attached to what? Not cyclo, just a benzene, right? So it'd be amino. Come write it. Really? Good enough. Okay, so the only one that had a bad thing here was this one. It should have been toluene. Okay. Other than that, we did good. Excuse me. You do need to make it toluene. Okay, so you need to know these. You need to be able to recognize them, be able to match them with their name. Okay, going forward. It's all right. It will be spelled for you. Luckily, you don't have to do the spell check. Okay, we're going to name the following. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, going forward, Luke 1, Noah 2, Joshua 3, Andre 4, Calvin 5, Ben 6, Kyle 7, Catherine 8, Ben 6. And Cambry 9. Who? Kyle, you're 7. Okay, get it up there. Get those answers up. On which one? 3? Thought you forgot something. Penta, di, and then E. Because there's 2 double bonds. Oh, arrow it back.
Where to start numbering so I know where the
Bond. James Bond always comes first.
So it starts here.
Right.
So it'll be
Yep.
1. Wait, do I put 1 right here?
You don't have to do it here because
the
you
ethyl
always
is on 3.
right. So you just go 3-ethyl cyclopentene
Okay.
because it's assumed that the ene will be on 1. If you have more than 1 double bond, you have to say where they're at.
Would that be it? 1,2-dimethyl cyclohexane.
Yeah, just no dash between there.
Oh.
Wow.
Oh,
You're
yeah.
talking to me about making syrup. Yeah. Wow. Wow.
So I thought it was.
So would be like 1, 3, benzene.
1, 3 cyclopentadiene. Pentadiene. Cyclo. Yeah, he forgot cyclo. Josh's issue.
Benzene
Put cyclo in front of it.
Cyclo.
Okay, if it's in a circle, you got to put cyclo in there, guys. Yeah, and that actually would be a very stressed molecule because they're right next to each other. Remember, it forced it into a plane, and then it would be forced into another plane, so they want it to be 180. Yeah, so it'd be really, yeah, it would break very easy because it's a very stressed molecule.
Luke is no longer my first man in my life. Look, it's 3 dash draw go dash. 3 dash draw dash 1 7 March 30th. Yeah.
Noah, did you get yours up here? Okay. Okay, let's double check these that are up and make sure they're correct. While Calvin's finishing, I gave him a low one again, sorry. Tall guy goes the lowest one. Oh, we got number 2.
Yeah.
Noah, okay.
I think I forgot the 2 at the double bond.
Uh-oh.
That was what was between. It should be between those 2, right?
The what?
Must there be a 2 at that double bond right?
It should be a 1. There should be a 1 and there should be 2, 3. Because you have to go through the double bond.
Okay. Oh well. How do you just erase the tiny?
You can't, it's sort of
2, 3.
2, 3. Cyclohexene. Okay, that works. Okay, let's go through these really quickly. Shh. So number 1, we've got, I have no idea what this is. This should just be chloro and the dye in front. Okay, that's it. And it's not 1, 2, it's just cyclohexene, because the ene would be at the 1. You don't have to write the 1. Okay? This one right here is not a toluene, it's just a methyl, and we would say 1-methyl dash, and then it's a cyclo here, hexene, because it just has 1 double bond. They're showing the hydrogen there, but they don't have to show the hydrogen. It has to go through the bond, but you want the lowest number, so I can count this way and go through the bond. Yes, you do need the 1. Okay, on this one, 1, 2, cyclopentadiene, great. On this one, 1, 3, cyclopentadiene, great. On this one, 2, 3, so 1, 2, 3, dimethyl, yes. They don't have to write the 1. You can, but you don't have to. Cyclo, I cannot spell, cyclo, that's a Y that looks really funky and weird. Okay, cyclohexene. This one just cyclooctene, and you don't have to put the 1, because wherever the double bond is, we count it. On this one again, 3-methyl, 1, 2, 3, yes. Again, you don't have to write the 1, cyclopentene. 1, 2, difluoro, and again, you don't have to have the 1 there, hexene. And then 1, 2, 3, 3-ethylcyclopentene. Good. Any questions with this? You see how we're doing this? Yes. That's because we're starting counting, but I know where the double bond is, but I don't know where on the thing the methyl is, because the methyl could be anywhere. So I've got to tell where the methyl is. Okay, going forward. we're now getting into equations. Hopefully that other stuff will go away. You need to know what equations happen and what the catalysts are for each equations. Okay? So when I'm trying to add a nitro group, I'm using HNO2. I don't know, you can't see those back there. HNO3, sorry, and H2SO4. So I'm adding H2SO4, or sorry, adding HNO3, and H2SO4 is the catalyst. Okay? When that comes on, what I get over here is, and I'm going to just draw a benzene ring with a circle in it, you're going to have the toluene, but then you'll have a nitrate over either there, or here, or here. So it can be O, M, or P. Okay, she could have any of those in the answer key, and that would be correct. Okay? On the next one, whenever you hydrogenate, when you hydrogenate something, you've got to have palladium as the catalyst. Okay? When you hydrogenate, you're just going to break that double bond, and you're going to end up with that. Yes? It's the catalyst. It's like the matchmaker. If you don't put palladium in there, it's a very slow reaction. It gets the hydrogen and whatever you're trying to break the double bond on to the same place and arranges them and gets them together. So it's the matchmaker. They sometimes use manganese as a manganese dioxide is often used as a catalyst. Okay, on this one, but this one has to be palladium for hydrogenation. It works the best. Okay, for chlorine, for chlorination or halogenation, remember these all started with H's. Okay, for halogenation, we need to use Markanoff's rule when we do hydrohalogenation. When we use just a regular halogenation, we just throw them in. So we got 1, 2, 3. We got 2 mountains and 1 extra here. So we would have a chlorine here and a chlorine here. Does it matter if I go up or down? No. I just need to know what carbon it came off. Okay? I am going to put it up on the web, so we good to go? Okay, so we're also looking now, we need to be able to look at things and determine if they're constitutional isomers, stereoisomers, or if they're identical molecules. Okay, remember constitutional isomers will have the same molecular formula. Stereoisomers will be cis and trans. And identical ones will be named exactly the same. So let's look at these first two right here. What do you think? It is constitutional isomers. They won't be named the same. They're not cis and trans, but they'll have the same chemical formula. C whatever, H whatever. Okay? What about these next ones? Be careful.
Identical.
Constitutional, they'll have the exact same molecular formula. Identical, you would name them exactly the same. And stereo would be cis and trans. Would you name them the exact same? Would it be 1, 2, 3, 4 bromo, 3 methyl, 3, 1, 2, 3, 4, 5, 6, 7 heptane? They're both the same. Now, we haven't learned them. These are enantiomers of each other. They're mirror images to a point. So we are going to just call them identical, or you could also call them constitutional isomers because they'll have the same molecular formula, right? Okay? All right, what about these next two over here? What are we going to call these two? They're not the same, but they are constitutional isomers. They're going to have the same molecular formula. One of them has 2 carbons coming off one place, but the other has 2 carbons coming off 2 different places. Does that make sense? Oh, one's a 5 and one's a 6. I didn't catch that one. So this is nothing. I didn't catch that one. We called it the other. Okay, all right, next one. Right here. These are stereoisomers. Good. What about these two right here? They are identical. All that's doing is showing the oxygen hydroxide's coming out or it's going back, but it doesn't have anything to do with. Why are these stereo? Because the dashed line means it's going back into the plane, and the solid line means it's coming up. And since it's in a triangle, if I looked at it like this and went like this on the ends, that means one of them would be here, whatever that was. That's a carbon. So this is a carbon up here and a carbon down here. This one up here is on both of them, the carbon's up. So we got a cis and a trans. Okay? All right, looking over here at this one right here. What do you got? Stereo, good. Now, what about these right here? They're isomers, but what kind? Constitutional. Okay, so you need to be able to look at them and be able to say, okay, yeah, they're the same formula, kind of thing. Okay, going forward. What type of stereoisomer configuration is more naturally common in fatty acids? It is cis, because trans fats are bad for you. Just remember that. Trans fats are not normal, not natural. Okay? What type of fatty acid has the highest melting point? Okay, so which one would have the lowest? So the most double or triple bonds. So the one that has the most unsaturated, the one that's most unsaturated. Okay? All right, going forward. Here we've got some hydration. Hydration uses Markov's rule. So does hydrohydration. Or hydrohalogenation, sorry. So remember that this one will split into OH minus and H plus. What was Markov's rule? Rich get richer and poor get poorer, and in hydrochemistry, hydrogen's the money, right? So when we break this, it becomes this. Where do I put the OH? On the third carbon going down, yes. So the OH would come here. Okay, let's do the next one. We're going to break the double bond, right? By the way, this is an acid, right? So I'm adding water in an acid solution. That's how it's going to hydrogenate. And over here, I'm going to get what? Where's my OH go? It'll come off the same carbon that the methyl group is coming off of. You see that? That is because over here, this carbon right here had no hydrogen, no money. But this carbon had one. So the carbon with one hydrogen got more hydrogen. The carbon that didn't have any got the OH. Okay, got the leftovers. Okay, going down to the last one here, we end up with this, with an ethyl group coming off. Where does the hydroxide go? One in, yes. So the hydroxide goes right there. If you remember that, you can get some good questions from it. Okay? Anybody have questions on how I did that? Okay, going forward. We need to be able to name these, okay, or draw the structure. So if I have, I'm going to actually have you guys come up and do these. 3, 4, whoops, I cannot count. This is 3, this is 4. Okay, here we go. Emma, 1, Richard, 2, McKay, 3, and Luke, 4.
P is the furthest away. M is right next to each other.
No, O is right next to it. Orthodontist. You're trying to get things right.
And M is like.
I just meant you give me space.
Okay, and P is like, yeah, okay. I just.
Okay, come on up and. Yep.
So we're gonna, do I need to put the CH3 since it's a
You can do it that way, or you can do the line out.
What order did the letters go? Primary, secondary. For the axis.
So, right next to each other, ortho. One away, meta,
Meta, that's
and then para,
para.
opposite.
Para's, yeah.
Yeah, you don't want to, because you tip over.
Can I just put a circle in the middle of the
Yeah,
circle?
that's fine.
Here.
Good job. Just erase it.
Just part of this, but
Okay, this is a toluene, not a benzene.
oh. I misspelled that.
It's okay.
It's stuff that's toluene, right?
Yep, it is.
Chloro something?
Yep, has chloro, dichloro, yep. Where are your dichloros at?
Numbers was like 2 and 3?
No,
2 and
this
4?
starts 1.
Okay, 1, 2, 3, 4, so 3, 5?
Yep. Dash.
Dash.
No, not there.
Oh, right there.
Yep. Okay, that's it.
Oh, that's it?
That's it. Okay, so you should be able to name really quickly, right? And you should be able to draw really quickly. So she could do one of two things. What is this? And she could have some diagrams just out. She could also say, what is the name of this structure? Okay, so you got to be able to go both ways. Okay, there shouldn't be a dash right here, so ignore that dash right there. Other than that, I think we did okay. Yep. You can put a CH3 here if you want to, or you can just have the line out. It's all right. Okay, so here we go again. This one, she's asking what's the reagent and what's the catalyst. This will be on the test. Okay, so first one, what are we going to use? Cl2, and what else? What's the catalyst? We're going to add Cl2 to it, but what's the catalyst? Okay, what about the next one? What are we going to add? Cl2 again. Remember with the benzene ring, it's not going to break the bonds. Okay, and we're still going to have FeCl3 as a catalyst. What am I getting on the other side? HCl. It's going to get kicked out. Okay, so it's a replacement. It's taking the H off here and replacing it with a Cl, so it's a substitution. Not an addition like the one above it. The one above it is an addition. This one is a substitution. Okay, what about the bottom one? H2O and H plus are acid. Okay? And it could be H2SO4. They could have put and H2SO4 here as a possibility. That could be an acid. Okay? Questions on this? Okay, you'll have a question like it. Exam time next time. So, I have got a hard copy of a review for you. We are going to go over this review in class next time. I would like you to try on your own to do as much of this as possible. And then Monday night I will put the answers up after we have a chance to go over it in class. So do what you can if you want to right now, or you can use it like a test when you get home. It's up to you. Yep. There are 50 questions.